Hello friends, this is a small discussion about combinational and sequential logic circuits. Now let's see the definition of a combinational logic. The output of a combinational logic block is only a function of the current input values. The output do not depend on the past outputs or inputs. The combinational logic circuit has no memory present in it, so it cannot store any past history of the system. The functions of a combinational logic circuit are specified in three ways. 1. Boolean algebra. This forms the algebraic expression showing the operation of the logic circuit for each input variable, either true or false. Number 2, truth table. A truth table defines the function of a logic gate by providing a concise list that shows all the output states in tabular form for each possible combination of input variable that the gate could encounter. Number 3, logic diagram. This is a graphical representation of a logic circuit that shows the wiring and connections of each individual logic gate. In precise, logic diagram is an implementation of a logic circuit. It is a simple diagrammatic explanation of a combinational logic. It has inputs and outputs and a no memory. A sequential logic has a memory. Therefore, the output depends not only on the current value of the inputs but upon the previous inputs also. A sequential logic circuit remembers the past history of the system. It has the notion of an internal state. Here's a diagrammatic explanation of a sequential logic. A combinational logic circuit with a memory is just called as a sequential circuit. A sequential circuit has the notion of an internal state. What is meant by an internal state? It is nothing but the reflection of the past inputs to the circuit. The internal state of a sequential circuit is represented by the number of state variables. The state variables can be implemented physically with the help of flip-flops. We all know the flip-flop implements two states, either 1 or 0. There is no other possibility. Each flip-flop can only represent two possible states. Therefore, if we have n flip-flops, we can represent a maximum of 2 power n states. Here are some examples of combinational and sequential circuits. Half adders, full adders, multiplexers, demultiplexers, encoders, decoders, magnitude comparators are examples of combinational circuits. Flip-flops, registers, counters, clocks comes under sequential logic circuits. There are two types of sequential circuits, synchronous and asynchronous. What is a synchronous circuit? The state of the device changes only at discrete times in response to a clock signal. The state of the device can change at any time in response to changing inputs. All the circuits are triggered with the same clock simultaneously. As they are triggered simultaneously with the same clock, they can otherwise be called as parallel sequential circuits also. The state of the device in an asynchronous circuit changes at any time in response to changing inputs. Different registers are triggered with different clocks, not simultaneously. So they are called as serial sequential circuits. The timing parameters for combinational and sequential logic is given below. For a combinational logic, we have propagation delay and contamination delay. For sequential circuits, the timing parameters are setup time, hold time, and propagation delay. The propagation delay is the time taken by the input to travel from the input terminal to the output terminal of a gate. Contamination delay is the value that indicates the amount of time needed for a change in a logic input to result in an initial change at an output. The three parameters for sequential logic are explained here. First is the setup time. It is the time interval before the clock where the data must be held stable. Hold time. This is the time interval after the clock had started where the data must be held stable. Propagation delay is the same amount of time taken for the input to cross from the input terminal to the output terminal. In precise, the propagation delay is the time that is taken after the setup and the hold times for the data at the input of a register to get itself copied to the output. Here's the timing diagram for a sequential circuit. The x-axis represents the amplitude and the y-axis the time. TSU represents the setup time, TPD represents the propagation delay, T hold is the hold time. The setup time is the time interval before the clock where the data must be held stable. The propagation delay is the time taken by the input to cross from the input to the output of the gate. Hold time is the interval after the clock where the data must be held stable. Thank you.